Hello everyone. So 2019 Math 3 Honors Semester 2 final exam review. Your final is going to be a little bit different than all the other tests, okay? It's going to be 10 questions. They're all going to be free response, and then there's one extra credit. So they will look just like these, okay? And you're going to have blank space to show all your work, and then you have to circle your answer on the page within this space. So you can see there will be one of this type. So we have 3 to practice. I'm going to make one on the video, and then you have 2 to practice. And the answer keys are provided to this review. So like there will be one type like this, one type like this. So if I'm giving you 3 examples, and I told you there's 10 questions, 10 times 3 is 30. So your review packet has 30 questions, and then so you see how there'd be one question from each type. Is this it? Yeah, 30 questions, and then this will be the extra credit is simplifying a complex fraction. You ready to go? Here we go. Probably 2 videos. I don't know, maybe a third. We'll see. I'm going to take my time. Okay, you see 1, 2, 3. Order of operation. You guys remember parentheses, exponents, multiply, divide, and add, subtract. You go left to right. So parentheses means you're going to start with the inside most numbers. Inside most parentheses, sorry. Okay, we can add these without affecting PEMDAS. So we could do 2 plus 13 is 15, plus 4 is 19, plus 4 is 23, and then something funny happens, so I'm going to leave that. Okay, what's 8 minus 5? 3, like that, divided by 3 plus 2, which is 5. Okay, I still have parentheses, so next we're going to do 23 minus 3, which is 20, and that gets rid of those parentheses. So now we have 20 divided by 5 equals, okay, look at me being a good math teacher, equals 20 divided by 5 is 4, and then I'm going to circle the answer. So your work is logical in nature. It goes down the page pretending there were lines here. It's not sideways, it's not up over here, it's not all over the place, it's down the page. If you make a mistake, you use your eraser, okay, to fix it. All right, let's go to this type of problem. Write the slope-intercept form of the equation of the line through the given points. So in order to write an equation of a line in y equals mx plus b, we need the slope first. So the slope is m. You guys remember the formula for slope? It's the second y value minus the first y value. Oh, see, I made a mistake, but you know what? I'm going to fix it. I'm going to fix it with my eraser, like that. y2 minus y1 over x2 minus x1. So let's see. Okay, this goes x and y, and this is the first point. X, y, that's the second point. So tell me what the second y value is out of these 4 numbers. The second y value is -3 minus the first y value, which is -5. Now what's a negative and a negative? Minus a negative turns to positive, right? All right, x2, what's the second x value? The second x value is -3 minus the first x value, which is 0. Equals, everything is equal to each other. The slope equals this, which equals this, and now I'm going down. -3 plus 5 is +2 divided by -3. Okay, even though this is showing 2 divided by -3, this is actually a slope of -2/3. So one negative gets moved out in front. We still need the equation of the line. Now, you could plug in this slope into m, and you could plug in 0 into x. Well, okay, sorry. What happens when you plug 0 into x here? M times x goes away. Well, 0, here's what we need to know. I can't pretend it's not here, okay? 0, -5 is the y-intercept. So it's almost like they gave us the y-intercept. So the y-intercept is b. So b is -5. So we're done, but what if they didn't give us the y-intercept? What if it was an accident and there's no 0 here? Well, then we would do y minus y1 equals m times x minus x1. So that's called point slope. Point slope formula. All right, so we keep the y, but then y1 is your first y value. So our first y value is -5 equals the slope. You keep the x, you got to keep the x and y, minus the first x value. The first x value is 0. Y plus 5, distribute the slope, and we get -2/3 x, but -2/3 times 0 is 0. So now there's no more 0. And then how do you get y by itself? We subtract 5. So we should, you know, the end of math 3, you shouldn't have to show -5 anymore. We're going to do 8th grade math in our head, and the +5 on the left becomes a -5 on the right. What are we supposed to do? Circle our answers, but it's not a circle. So you could say box your answers, but it's not a box either, because a box is 3-dimensional. This is actually a rectangle. So you could say rectangularize your answers if you want. That's a big word. Write the slope-intercept form of the equation of each line. Easy peasy lemon squeezy. Y equals mx plus b. So can you find the slope from a line? What we're going to do is I'm going to try and find 2 points that cross at the crosses on the graph. So no, 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 here. I see that's at -1, +1. Those are integer numbers. No, 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 no. It's not -4, but we're going to say this crosses at -5. Okay? So our y-intercept b is -5. That's where it's crossing the y-axis. So the y-intercept is a coordinate point. Wherever x is 0, that will give you the y-intercept. 0, -5. All right, now to find slope. Remember, rise over run. Hi, from this point, are you going up or are you going down to get to the other point? We're going down. So we're going to go down 1, 2, 3, 4, 5, 6, and over 1. So we have a -6, +1 is our slope. -6 over 1. X, you can circle that. I'm okay with that. Or you can circle it, -6x minus 5. Number one mistake kids make is they would say that, oops, we're out of the video. I'm sorry. There we go. The biggest mistakes kids make is that students make is that they say that this was a positive sloping y. But it's not. It's a negative slope. It's going down. Like, that should be so obvious that if your graph is going down, your slope is negative. This graph, is it going up or down? It's going up, so your slope is positive. So don't go, oh, I messed up. Oh, I made a mistake. Oh, I forgot. It's like, no, we don't forget. We pay attention to detail and we make sure it's right. This is going down, so our slope is negative. Moving on. Oh, I like this one. Okay, I made up this one myself. Are you proud of me? Here we go. Solve each by factoring. These are quadratic equations. They are already set to 0, so we kind of took that fun out of it. But step 1, we're going to factor. Always check for a common factor. So does this one have a greatest common factor? 8. Does 8 go into 32? Yes. Does 8 go into 40? Yeah. So we're going to factor out the number 8. Now 8 times what is 32? Times 4. 8 times what is -40? Is that -5? Yeah. Not a fan of the letter N, but it's okay. I can get over it. I'd rather it be X because I want you to graph this. And you're like, what do you mean graph it? I'll show you. Okay, what multiplies to get -5 but adds to get a +4? That's going to be a +5 times -1. +5 plus -1 would be 4. Okay, fantastic. So n equals -5 and n equals 1. Those x values give you a y value of 0. Do you remember these? These are called zeros. Are -5, comma 1, and 1, 0. So when x is -5, this would be 0 and would make the whole equation 0. And if you plugged in 1, 1 would be 8 plus 32 minus 40 would equal 0. So these are called zeros. Okay, I added this part. State the y-intercept. So if this said y equals, see how I changed it to x? Oops. Okay. If this said y equals 8x squared plus 32x minus 40, what is the y-intercept? The y-intercept, y of 0, would be if you plug in 0. All right, what do you get when you plug in 0? Y of 0 is equal to negative 40. Ready? Solve by factoring. These are the solutions. And then this is the y-intercept, so I've answered those questions. Plot the 3 points to graph a little parabola. Okay, watch. So here we go. We have our x, we have our y. The x coordinate points, we're going to graph 1. So that's 1, and then we need to go to negative 5. 1, 2, 3, 4, 5. And then what's our y-intercept? Negative 40? Okay. 10, 20, 30, 40. Here we go. So watch. 1, negative 5, those are the zeros, and this is the y-intercept, and it's a positive parabola, so it's going to look something like this. That's all. Just do you know that these solutions go on the x-axis and the y-intercept goes on the y-axis. Okay, so the zeros, the y-intercept, and the graph are all part of that question. How are we doing? Good? Good. Graph the equation, but describe the transformation. So we actually have to describe the transformations before we graph the absolute value equation. Okay, so the absolute value, y is the absolute value of x. Do you remember that? It goes like this. It's 45 degrees going in both directions, 2 lines. So that's the parent function, parent. Okay, this 3 in front, this 3 means it's a vertical stretch. It's T-R-E-T-C-H. Vertical stretch of a factor of 3. Vertical stretch of 3. That means, what is this slope right here? This slope is 1, 1, 1, 1, right? So instead of a slope of 1, we're going to have slopes of 3, but it's positive. What would happen if it were negative? It'd be going down, okay? Now what about the points here and here, the 2 and the negative 4? We could say, there's 2 ways to describe this. We could say we have a new vertex at negative 2, negative 4. Or a different way of saying that is that it shifted left 2 and down 4. And are you remembering why is it left 2? So inside the absolute value or inside parentheses, we do the opposite. And so it said plus 2, so we're going to go left 2. But outside the parentheses, that number in the end just means down 4. You keep that sign. Okay, you ready? We got to do the vertex first before we do the stretch. Okay, so we're going to go negative 2, negative 4, like that. That's our new vertex. We shifted left 2 and down 4. And it's a positive 3 slope. So we're going to go up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1, like that. So it should be tall and skinny, and then do it in the other direction. And use like your ID card or a credit card or something. I hope you don't have credit cards. Those are bad. Okay. Am I still on? Are we still on? Do I have time for one more? There you go. Describe the transformations, graph the function. You don't have to graph the original, I was just showing you. Okay, do you hear me sigh? I'm going to save this one for the next video because this was an important topic that we kind of did too fast in class and I think you need a lot of help on. So we're going to save logarithms. We did good. I think we got halfway, yeah? Okay, good job. Thanks for watching. We'll see you next time.